Now, moving on to the two-way chi-square test. This goes back to the idea of a cross-tabulation, which we covered in Chapter 2. When we want to test category frequencies for two or more independent variables that are dichotomous, we want to use what's called a two-way chi-square test, also known as a chi-square test of independence. And the calculations are the same as with a one-way chi-square, except now we actually calculate the expected frequencies rather than just taking n and dividing by the total number. And we do this by the expected frequency is equal to the row marginal total multiplied by the column marginal total divided by n. And again, this is how you get these numbers we can see in the Revel text. So here, for example, are our column and row totals. Here I have a preference for government size by political orientation. So I have two dichotomous variables, and I want to look at the category frequencies of each one. So in political orientation, I have two levels, liberal and conservative, and in terms of preference, I have large versus small. These numbers here represent our category frequencies. And so I can have row category totals, in which case I'm adding up all of the rows. So I want to know what my total is for those that prefer a large government. So I have 15 plus 10, and I have got a total row total of 25. Likewise, those that want small government, I have 5 plus 10, which gives me 15. And then I have my column totals, in which case I'm looking at how many have identified as liberal, 15 plus 5 is 20, and how many have identified as conservative, or 10 plus 10 is 20. So then remember that my expected frequency is the result of taking my row marginal total, which in this case would be 25, okay, multiplied by my column marginal total, which in this case would be 20, okay, and then divided by n, which is 40. So if I take 25 times 20 divided by 40, then I get this 12.5, which is my expectation for that category. Now, chi-square tests demand that the sample sizes are not too small. If I have expected frequencies that are less than 5, I need to use what's called the Yates correction. When they're greater than 5 or less than 10, then this correction will reduce the overall size of the chi-square, and it's only appropriate for 2 by 2 tables. And so you'll notice that the equation is pretty much the same. We still take the sum. We still take the observed minus the expectation, but then I subtract 0.5 from that. Now, in terms of the assessments for this module, you won't have to do this correction, but in practice, category frequencies between 5 and 10 are common, and so I wanted to bring this procedure to your attention.